Good morning, Aryavita Sahu, sir. Good morning, sir.
Good morning. Am I audible?
Yes, sir. You are audible now, sir. Sir, we'll be starting the session soon. After
Yeah.
all the dignitaries joins, we'll be starting.
Yes.
Okay, sir. Good morning, Dr. Amit Bansiwala, sir. And good morning to Ravi Mandila, sir. Sir, we will be starting the session shortly.
Good morning, sir.
Good morning, everyone.
Good morning.
Yeah, good morning. Very good morning to you all.
Good morning. So, hello, Amit ji. How are you? So, you are in mute. So, I need to.
Yeah, sorry. Good morning, and I'm doing fine and hoping same for you all.
Yeah. Hello, Ravi ji. Good morning.
Good morning, sir.
Good morning. Rajesh Bhai sahab also joined. Hello, Rajesh Bhai sahab. Namaste.
Namaste, namaste.
So we'll start the things.
Yeah.
Let's wait for 5 to maybe 5 minutes. Maybe other people are joining. So maybe Bharat ji or Sandeep ji may join. Hello, Gaurav ji, good morning. Hello, Gaurav ji, good morning.
Good morning, Gaurav Trivedi, sir.
Bharat ji also joined. Hello, Bharat ji, good morning.
Good morning. Good morning. कैसे हैं?
बढ़िया.
Very good morning to you.
Good morning.
Good morning, Bharat sir.
Good morning, Ravi sir. कैसे हैं? How are you?
Fine, sir.
सॉरी एक्चुअली एक कॉल पे था, सो मतलब अटेंड बीच में ज्वाइन हो गया, बट मुझे कॉल भी अटेंड करना पड़ा. प्लीज गिव मी सम टाइम, है ना. वी आर स्टार्टिंग फुल.
Yeah, Rajesh ji also joined.
हाँ, नमस्कार राजेश भाई सर.
So most of the people have joined. So from the coordinator side, so particularly Praveen Pradi and Professor Manas yet to join maybe. Gaurav ji, can we start maybe? Rajesh ji?
Sir, with your permission, can we start with the session?
Yeah, we can start. First, formally, let's welcome all people. Formally, let me welcome Rajesh ji, then Ravi ji, Bharat ji. So let's welcome to all particularly panelists. And research methodology workshop is really a necessary thing. How to start the research, what should be the not only the doing a very good new research, but how to publish the things, how to create impact, particularly novelty, how to create novelty or how to design for the novel things. That we'll discuss in these things. And let me introduce here Dr. Rajesh Biniwale, Neri. He will be delivering a talk. Then Chopre ji, then Amit ji here, he is also present, and Professor Ashish Pandey also delivering the talk in the research methodology. So we'll get to know actually many good things how to do research and mostly general and philosophy how to do the things. And let me hand over to Professor Rajesh Biniwale. So to say something about the research methodology. Then we'll start the session after doing the inaugural address. So Rajesh ji, hand over to you. is still the things. So Gauravji,
Yes, yes.
please say something. So Rajesh is not. I'm trying to hand over to Rajesh, but he's.
Okay. So I just welcome everybody in this inaugural session, and this particular workshop is on the research methodology, which is one of a very important part of all the scientific community. And in fact, how to conduct the research, how to effectively produce the data, and how to effectively you can infer the results, the outcomes. That is very, very much important. It has multiple, you can say, angle, like even how to conduct the effective and the efficient literature survey. That is also one of the very much basis of this part. And all this kind of you can say issues will be discussed in this particular research methodology joint FDP program, which is being conducted in association with Research for Resurgence Foundation Nagpur and IIT Guwahati. Our experts, Dr. Rajesh Vinivale, Dr. Professor B.A. Chopre, Dr. Ashish Pandey, Dr. Amit Bansiwal, they are specifically one of the well-known expert in this particular area, and I believe that all the participants in this course or this course precise. So what I'm thinking that in this particular course, all the participants will really get benefited by their sheer experience and the different talks which is being held by them. So I wish everybody a very good luck for this course. Stay safe and healthy. Thank you.
So Raviji, do you want to say something? So Raviji.
Good morning, sir. Welcome to all the participants from MNIT Jaipur. I hope with this course, all participants will be able to get a good insight on how to start their research and carry it forward. I was expecting Vineet Savla sir also to join me. He said he would be joining shortly, but I think he got held up somewhere. Thanks to all the participants for joining.
Okay. Let me ask Rajesh if he will give a talk, but basic things I can say. Rajesh bhai sir, can you please say something, some words for this research methodology also?
Yeah, sure, I will tell you. See, we have been doing a lot of research as a research laboratory, as well as a lot of research is going on into the academic area, where some IITs kind of Institute of Excellence are doing their own way. The state university doing their own way. But what happens is when we look at the entire research being carried out in this academics as well as outside the academics, most of the research is not going to be utilized in the field. It is not being used in the field. Say, for example, last year almost like 40,000 PhDs were awarded in the country by various universities. Now, if these 40,000 universities would have been solving some of the issues of the India, probably we would have solved at least a number of issues, and maybe if we can identify, I don't think more than 1 lakh issues would be there into the country. So we should be able to solve this in maybe 3 years if all these PhDs were working on the issues which are related to India. So let's say 5 years. Within the 5 years, we would probably solve everything as far as where the research can contribute and solve. But that's not happening. That's not happening. And the second is when we try to publish the papers, most of the people have the complaints that they have got a lot of rejections, many times, a lot of suggestions, and so and so. So what is missing? What is missing? And then the third point is regarding the IPR generation, where the patents are being generated, but of course, worldwide also, the percentage of the patents which are filed, granted, and commercialized, there is a there is a very small percentage which actually goes to the commercialization, which is in some beyond decimal points only. But this is something which we need to also worry that what is that we are missing, novelty we are missing. So what we thought was to collect the ideas and to collect the experiences of the experienced researchers who are going to be the faculty, who are faculty to this course, and let them tell to the younger generation, the next generation of the research, that what are the areas where you need to concentrate, what are the areas in terms of what are the methodology areas where you need to concentrate on the research, so that your research becomes a fruitful and purposeful research. And that purposeful research is very important. What is the purpose of your research? Purpose of the research is not getting the PhD. Purpose of research is not writing a paper. Purpose of research is not writing a patent. Purpose of research is much beyond it. And therefore, what we thought that we will start doing this particular process, and we will try to pass on the information, we'll try to build up the knowledge base around the research methodology. And that's what the aim of this particular course as well. And more will be spoken by Chopra sir is also here. So he will also speak, he will also put up his views. And Dr. Amit Bansiwal is also here. So let them put their views also. These are some of the very few key points, and to start with, what you expect from the course. That's where I will stop. Thank you very much.
Thank you, Rajesh. So let me ask Chopra ji. Chopra ji, please address the research methods participants. Chopra ji. So I request Chopra ji to address the audience participants.
Chopra sir, Professor B.A. Chopra, sir. I think
Might be the connectivity issues. We can ask Amit Bansiwal to speak, and then Pentag.
So Amit Bansiwal ji, so please address the participants.
Yeah, good morning. Am I audible?
Yeah, audible.
Good morning and welcome all the panelists and participants. I can see a lot of participants from throughout the country, different parts of the country. And already the importance of this particular program and the area is already highlighted by Dr. Rajesh and other panelists. And I think it is, as mentioned, it is very, very important to align our activities and particularly the research activities with the larger interest of the country and society. And for that, this program is going to contribute a little on those lines. And I'm going to mainly cover about the instrumentation aspects of particularly related to environmental sophisticated instrumentation. As we all know, for any research, instrumentation is the backbone of that particular research activity. And without proper data and the experimentation, it is really very difficult to arrive at any desired outcomes and results. So this is another important aspect of instrumentation which I'm going to cover in this particular program. And I think this is going to be very, very helpful for all of us. And I wish all the very best to this program, and let us look forward for highly interactive. My only request is to please be interactive and ask or raise or discuss whatever you feel, so that we all can really make it a very fruitful program. Thank you.
Okay, thank you, Amit ji. So Binit Saulaji and Sanjeev Manas ji also joined. So I request Binit Saulaji, can you please say something about this research methodology workshop to address all the participants? Saulaji.
Professor Sahu, am I audible?
Yeah, audible.
Yeah, thank you very much. I'm happy to be part of this program, as well as the audience, part of the audience today. And I invite on behalf of all academies, all the participants to listen to the eminent speakers in this. We, as a faculty, all have been involved in research and documentation. And I think this program is actually to expose us to best practices by other researchers regarding the data collection, experimental setup, the documentation, and sometimes review also, that part. So I should thank all the speakers for having kindly consented, for taking their time out. And thanks, Professor Sahu. I welcome my other colleagues from other academies. Thank you, Professor Sahu.
Thank you, sir. So now I request Sanjeev Manasji to say something to motivate all the participants.
Yeah, hello.
Hello, you are audible.
Okay. Good morning to all, and I'm really very happy to be part of this discussion on NCAN online course on research methodologies. First of all, I want to thank and also congratulate IIT Guwahati for the ICT Academy, IIT Guwahati for conceiving and devising this program. We have about, I think, 40 participants from ICT Academy, IIT Roorkee. And I'm very sure that this will be a very interesting course. It is slightly not a traditional course that we have been doing, but all the more it is very important. Before we start thinking of research, we have to know how to do the research. So in this particular program, we have panelists and invited guest speakers who will tell you various techniques, methodologies, as well as processes of carrying out research. The selection and analysis of data that we obtain is also very important and part of the research methodologies. So I'm sure that this particular program will be beneficial to the participants and help them to strengthen their techniques and methods of doing research, make them more systematic, as well as also prepare them in a way to attack the problems that they are working on, to come up with novel solutions and innovative solution to various challenges in the research domain. I also want to thank all the participants of all the participants who have registered at ICT Academy, IIT Roorkee. So we have our program manager here, Mr. Dr. Anurag, as well as supported by some other staff. And if you have any difficulty, if you face any issues, please feel free to contact Anurag or me during the course of this program. And let me again thank you all, and I wish you all the very best and very happy learning. And I wish you to see you again in some of our other programs. Thank you very much.
Thank you, Professor Manas. Now I request Dr. Bharat Gupta to say something. So Bharat Gupta, Dr. Bharat.
Yes, Dr. Sahu, thank you so much for inviting me and say a few words in the August gathering. First, I would like to say a very good morning to all the panelists and the participants who have joined this program. And on NIST, NIT Patna, I welcome you all. And as all the panelists have already told about the code, so I will not say much. The only just one line I will say that the importance of research methodology in the life of researcher is so important, because if he don't know how to do the research, he cannot reach to the goals. And it's very much important that Dr. B.H. Chapode sir has said that we are not doing the research only for papers, only for documentation, and only for patent. It is something else that we are trying to achieve. So I hope that with this course, the participants are looking forward not only for the how to write the papers, how to write a patent, but they will look forward that how they can develop the system that which is useful for the society and at a large. So with these words, I congratulate all the academies that who have organized this course, and from NIT Patna, Dr. JP Singh is also with us, but today he's having some meetings, so he could not join over here. And we have 3 proctor coordinators. Along with that, we have with NIT Patna around 150 participants and joined in this program. And I hope everybody will be very, very beneficial. And so my all best wishes to all the participants. And we are very thankful that all the eminent speakers have given their kind consent to deliver their expertise in front of the participants. I hope that everything goes very well and they will learn in the next 2 weeks. Thank you so much.
Thank you, Dr. Bharat ji. So now I request again B.H. Chopra ji. So he's connected to his mobile.
Yes. Yeah. Am I audible?
Yeah, audible.
Yeah. See, there's some problem with the video, but I'll talk, I think. Okay. Right. Very welcome everybody for the today's, I think, the program. Professor B.H. Chopra, Anusantam Prakoshta Pramukh, Bharatiya Shiksha Mandal, Nagpur. Friends, I'm very happy to be with you on the occasion, I think, of the inauguration session of this particular wonderful, I think, research methodology, I think, workshop. And I must tell you, practically in the 21st century, the explosion of knowledge. Be science, technology, engineering, medicine, agriculture, humanities, social sciences, in every field, mathematics and physics, explosion of knowledge. And if you see the knowledge growth curve, you're surprised to know that knowledge has been doubling after every 24 hours. So you can able to imagine the kind of the knowledge being created, being developed in the world, I think. I was going through this, I think, the details, I think, of the research references, I think, on the internet. I'm surprised to know that 120 billion references are being searched every day by research across the world, I think. And therefore, in view of the background, in understanding the fact that explosion of knowledge, a researcher has to understand that how to perform the research, I think, and how to make sure that I am not repeating the research which already has been published and or which already has been done, that I think. And from this point of view, I believe a researcher has to develop independent thinking capacity in the domain area of his subject, I think, and try to be very, I think, innovative while designing the problem, developing the hypothesis, I think, in general, in Indian conditions. Our research is just like incremental, I think, We do research for the sake of publications. We publish in high impact factor journals. However, very rarely we try to protect our research, or what you call in form of the patents or IPR. And even though we get the patent, whether patents are applicable and or whether they are functional, that we never ever see that, I think. From that point of view, it's very, very important, I think, for researcher to develop that, I think, that what is most important is not just a publication. It's not just getting the degree PhD. It's not just, I think, getting the patent. But I believe that purpose of the research truly is development of mind. Development of critical mind, I think, And from that point of view, the cultivation of the mind is a basic objective of research and innovation. That I think we'll have to see. We have to open the mind, I think, And generally what happens in Indian scenario, I generally observe that, when students come for a PhD or research in general, I think they ask the professor, sir, I'm new for research, you please tell me what to do. And this very clearly indicates that I think this is scenario across the country, I think. A professor tells the problem to the student, and that is why I think they start doing the research, doing the literature, the research, developing the problem, so and so forth, I think. They follow the professor, they follow the guide. But a question basically which comes to mind that, how much is independent thinking about the problem, about the hypothesis, and about objectives by the students, I think. How can research can be very innovative, I think. And from that point of view, I like to put a lot of new ideas, I think, of developing a research mindset that I think we'll able to address, I think, And overall, I believe that in my 4 hours interactions with you all, I think, I'm able to discuss with you in detail, I think, how to develop the cognitive skills for research, I think. Development of cognitive skills for research is of paramount importance, I think. And that we have to nurture during the course, I think, of research, I think, and innovation, I think. Again, we always compare research and innovation, I think. We have to decide, do we want to become researcher or we have to become innovator, I think, or we have to become both researcher and innovator, I think. So these are two new, I think, lines, I think, of research, I think, which I think I like to discuss, I think, with you in my, I think, interactions, I think, on 20th, I think, of this April, from morning 10 o'clock to 2 o'clock, I think. I welcome you all. And I believe that, I think, in this, I think, research workshop, I think, after our, I think, once we complete our thought process, I think, I like to have participation of professors and researchers in the workshop, I think, and that active participation from both sides, from myself and by researchers, will be, I think, of great use, I think, in, I think, developing this, I think, research workshop, I think. I believe and trust this research workshop will provide new insights of research and innovation and develop a new path of your, I think, thinking in your, I think, career, I think. I hope to see you on 20th. I wish you all the best, I think, for all the days, I think, for all participants. Thank you very much.
Thank you, Chowpadeji. So almost everyone from the panelists have already given address to participants. Okay, so I thank you all the panelists, Rajeshji, Chowpadeji, Manasji, Saulaji, and others. So they really told many good things about research methodology, and the main points are purposeful research, how to use particularly benchmark data or instrument, where and how to do performance, do experiments, and in general, paper and patents are byproduct or byproduct outcome of actual research, but actual objective should be solving the real problem of the society. Okay, this would be the our main motto, and I thank all the participants. I hope everyone will learn many things about research in this research methodology workshop. So thank you. So officially, this inauguration is over. Everyone have addressed. All the panelists have addressed. Now we can start our main research methodology sessions. First sessions will be taken by Dr. Rajesh Pinivaleji. And let me hand over to Dr. Rajesh Pinivaleji. He will talk about basic of research and particularly type and general aspect of research, area and topic and related things. So Rajesh Pinivaleji, let me hand over to Rajesh Pinivaleji. So Rajesh Pinivaleji, please take over.
Thank you, Babuji. I'll just start. So the first thing which I'm going to is just to set up the tone of what I'm going to take in the second session after the break. So we will go into the much more details of everything, but it is something which I'm trying to put together right now. Is the first thing is to understand what is all about the research, what is that, how to select the research topic, and so on and so on. So generally, what happens is, am I audible? Just wanted to confirm it.
You're audible.
Yeah. So
you're audible. If you want to share your slide, you can share maybe.
No, right now I don't want to share. I'll share it in the next session. So
okay.
I think share button is also not active. So you have to give the permission for the share. The administrator has to do that. Okay, so what is important in selecting the research topic is generally what happens whenever a researcher comes for carrying out his research, when he feels that he is interested, many times it's not interest, it's just because of some compulsions, people try to join the research. And when they come to the lab, most of the time what happens is, in case of our labs also, our type of labs also, and also in the university, generally the topic is given by the guide for which the guide has been working for decades together. And the second is the kind of work which can be carried out in his laboratory. So the constraints are already defined. So people don't want to go outside those constraints. To some extent, this is pretty obvious, because somebody has to complete his research work, which is degree-oriented research work. And therefore, this is something time-bound, a bit of time-bound. Although there may be also some long years may have been taken in some cases, but at the same time still has to end at certain point of time. and has to carry out within the limited resources available in terms of facilities, in terms of expertise available with particular institution which he joins. He or she joins for the research. Now, this particular aspect is definitely the first thing which is killing the research in the country. The whole purpose of the research is not made. It is just to carry out the work for the requirement of award of a particular degree. That is what is the entire purpose it reduces to. And therefore, there is no larger purpose which can be thought over. Moreover, when somebody joins and then some few things are given, since it is being worked by many researchers in that lab previously as well, many students might have worked on that. So most of the aspects are generally taken care in first few years. And the latter part of the time somebody joins, it's basically the very marginal difference or very marginal improvement in the existing work is proposed. And therefore it is marginalized also. So first of all, there is a purpose is lost. And even whatever the purpose is, say for example, only to get the award of the degree, even in that, the research scope is marginalized to a large extent. And therefore, what I was saying was whether it can be useful. So it is not useful at all. The initial remarks when I said almost like 40,000 PhDs are awarded here. And that's the highest. In the COVID period, the highest possible PhDs were awarded in the country. And most of them are not useful. I'm not doubting the research which they have done. I'm saying the constraints under which they have worked, it is something which is making them not useful to the society, not useful for the industry, not useful for any other purpose of solving anything. So when we started talking to the people long back on the research, this is now we have been working on in this area, not by self doing the research, but trying to motivate the researchers, trying to bring the paradigm shift into the research arena. What we understood was we are also constrained in it, in the universities particularly, by registering a topic of PhD. Once you register a topic of PhD, you have to stick to the topic. You cannot change any preposition also. Like if you want to change somewhere it is for, and if you want to change that for to off, it is not allowed to do. You'll have to submit the same title with a thesis with the same title, which was registered when you registered for the PhD. Now, this is something which is very, very funny because many research, if everything was known before that what you are going to get, then what for the research was made? There was no need of research when everything was known before. And therefore, the topic writing is something which is again a misleading concept which we thought. There may be arguments against it also. You'll have to have a topic and then only you can work on it. But within the topic, we should have something different. Well, beyond topic, we should have. Now, what is that different? I think we should write the purpose of the PhD and register the purpose of the PhD or register the purpose of the research rather than topic. And this is very important. And I would like, this is I'm very happy to inform you that at least 3-4 universities in the country have changed their rule now. They are writing the purpose of the thesis first, purpose of the PhD student studies, or purpose of the research, and that is purpose is getting registered, not topic is getting registered. So that once your purpose is registered, topic can be selected, a topic can be given the name at the end of the research and after the findings are for you. What is the finding? Say for example, how the topic registration can be misleading is, suppose I decide to generate a topic that a particular composition of a chemical, if it is converted into a tablet, is useful for curing the cancer. And during the study, I do not find so. And if now I cannot say this, in the thesis because my topic was effectiveness of something, effectiveness of this tablet. So I have to stick to that topic. Whereas my findings are entirely different. So am I really doing the justice? I might have done the very genuinely research into the lab, but while reporting, I'm compromising. So to avoid such compromises, this has to happen. In fact, I will tell you one of my own experience. When I joined the Japanese lab for my research work, for my PhD work, my topic was something different. My topic was related to catalysis, but it was related to auto exhaust emission. So as usual, why I sent the topic was because I was from India and I was trying to understand it is topic which is important. But then when I reached Japan, my professor said, that is okay, whatever the topic you have written into your form when the fellowship was awarded. Now let's write the purpose. Let's write the purpose for which we are working on the catalysis. So we wrote. And to my surprise, I used to go every year to Japan for a few months to work over there. And next year when I went, my topic was changed. He said, now let's assume that on this topic you are working. And that too, he was giving topic to only me and one of more Indian student. Others were given only purpose. I had also had a purpose of the research, but at the same time, some topic was projected. Then third year, again, the topic was changed. And now I got worried because I had a experience of Indian university. So I went and asked professor whether I'm really going to get a PhD from this university or not. See, the third time we are changing the topic. I said, don't worry about your topic. Topic is not important. Topic we will decide when we publish thesis. The word he used, when we publish the thesis. And I came to know at the end of the PhD that till the PhD was, till the last viva was done, there were 2 or 3 vivas, till the last viva was done, and it was, result was declared that I found fit for the awarding of the PhD. Till that time, my thesis was in a file, in a, what do you say, that clip file, it was there. It was not a bounded form thesis till that point. Once it was decided that it is, this work is worth enough to award the PhD, then my guide said, now you should make a thesis in a bounded form and then publish it. So understand the procedure, understand the way of the flexibility of putting up your findings, research findings in a more effective way. So the flexibility was available till the end of the last viva, that whatever we want to change in the thesis can possibly be changed. It is not necessary that one, and in our cases, mostly the bounded form of the thesis is submitted with that topic, and then it is given to the reviewers. The reviewer, whatever the reviewer says, probably those answers are given, but I don't find in most of the cases, I don't know, in some cases if it has been revised, thesis has been submitted, but in most of the cases, I never found that the revised thesis is submitted. Thesis remains the same, it was submitted. Might be some answers to the reviewers has been given, but the thesis doesn't change. And then what is the purpose of this evaluation of the thesis at the end of the day? So to understand that, why I'm talking now, why I'm making so much of a stress on this is, there are various aspects of laboratory research which is happening. One is selection of the purpose, selection of the laboratory, selection of the areas in which you want to work. Second is the way you have collected the data, the way you have analyzed the data, the way your findings are there. Now, how do we arrange these findings for putting up into a particular document? For this point of time, when I'm stressing on the thesis, is the thesis, but also some publications which are mandatorily being done during the research work. So what you are proposing to the world, whether it is correct, whether the reviewers have seen that, whether this has been evaluated by the experts, whether it has been corrected time to time, midterm corrections has been taken, and what you are giving to the world, because your thesis is not just because you have, it's not a partial fulfillment of the requirement of the degree course, but it is also contributing to the advancement of the science in that area. And if that advancement of science is not addressed, then the purpose is very, very marginalized, very, very minimal, and the lost, I would say. And therefore, it is very important for while selecting the topic, while selecting the areas, you need to work on many, many aspects which are I was telling that the flexibility has to be everywhere. And this flexibility, we were working on to bring in this flexibility into the universities of the country, Bharatiya universities. We want to bring this, and wherein, how do we bring it? We have to go talk to the researchers. We have to tell them what are the experiences which we have. Most of us who have done work outside, they have the similar experiences. So they need to share these experiences. We decided to share. We decided to create this group who will share these experiences and bring those ideas, bring those methodologies to the country. So that's the one point of it. Second is, when I used to write a paper, at that point of time, I was already a scientist, so we had a experience of writing the research papers, publishing them. So there was not big difficulties, but I also learned few things from professor to how to guide those research papers. And why I'm telling these examples from my own experiences, because these are some of things which taught me few things which were required to be taught as a researcher. And this opportunity you don't get when, at least in university, you might get possibly. But when we do such kind of PhD work from the research institutions, you have a lot of work to do all around. And unfortunately, we become the very expert the day we join. So that's not true. That's not true. This should not happen. So to tell you how do we decide, I used to discuss and decide on the papers. This is very interesting. Suppose I have worked on certain areas and collected certain data and decided to write a manuscript on it. So what we used to do is I used to collect that entire thing, compile those data, prepare the graphs, tables, some figures, and go to professor to discuss it. Professor used to find it, whatever the way he wanted to discuss, he will ask a lot of questions. And at the end of the day, when we discussed it, he will ask two specific questions. And these two specific questions, I believe we should ask to ourselves at every point of time. After those questions being answered to the professor for that particular point of time, I started asking those questions to my students and myself as well, whenever we plan to write a manuscript. The one other question out of two was like whether whatever the data you have collected, does it make a sense? So he used to ask that particular question, does it make sense? Whatever you plan, whatever you are saying, whether you have enough data collected, enough evidences, direct evidences collected, so that what you are saying, suppose for example, if you are working on the nano materials, then how do you decide that your catalyst or your material is of nano size? So you do the characterization. You do the characterization, different type of characterizations are there. So he generally used to ask what is the data triangulation you have done? What are the different methods you have used to decide that the nano size of your material is particularly in this range? It is really nano size first, and whether it is in this range, whatever the range, it is there. So it's not one single characterization technique, but the multiple characterization techniques, if it has combined together and worked out, then it makes a sense of saying that it is a nanomaterial. And similar thing is used for its application. Similar data triangulation methods are used. So first of all, you have to say with the justifications, with a lot of discussions, that it makes a sense. It's not only that what you are saying is correct by just giving the direct evidences, but also why you are doing also has to be surely said that it makes a sense. So once you decide and once you define that it makes a sense, the next question is asked. So the next question professor used to ask was, does it contribute to the advancement of science in that area? The question was asked for the science, but the science means the kind of research methodology, scientific methodology which you use in any field. So let it be engineering research, let it be medical research. It's contributing to the advancement of science in that area. So if you answer that yes, it is contributing into that area, advancement of that area, then you have to justify how. So for that, as we do the literature search before writing any manuscript, so we have to create a chronological and also a developmental point of view in that area, that what has been done before, what is the significance of those developments, why those developments has contributed, and therefore how I am different than this and why I am contributing. Either I am proving something which has been said previously, either I am contradicting something which is previously said, or either I am finding something very new which is not previously said, and why it is required to be reported. So all those, when we say, then we can be justified that it does contribute to the advancement of science in that field. And after that only, he used to say, okay, go and complete the manuscript now, write the manuscript. If both of these questions are not addressed satisfactorily, in fact, if you don't address the first question satisfactorily, then the second question doesn't arise at all. But if the first question or the second question, whenever you get stuck, you have to go back to the laboratory, work more, bring more data, bring more justifications, and then only it was allowed to write the manuscript. Forget about the sending it for the publication. Forget about submission it to the journal. It is something which is far-fetched ideas at that point of time to send it to the journal before this is being finalized. So it's a perfectly the mechanism which we need to follow for the research. So this is something which I am talking about, the basics of the research, where we have to work on research areas. We have to say the purpose of the research and not the topic of the research. Topic is fine. Topic would be decided. Topic would be decided when we finally write a manuscript or finally we write a thesis. At that time, it will be there. So how do we select the research area or the something? A research topic is generally specific to the question or hypothesis or a problem, whereas several such hypotheses, alternate hypotheses, several questions which are required to be answered in that is something which is called the area. And therefore, we need to work on the broader aspects of the area. Now, this is like when advancement of the science in this particular advancement in the particular scientific area, if we can target. But what is the again purpose? Purpose is either enhancement of the lifestyle of the human being, health related things, environment related things, or it could be the productivity in some areas. Say for example, industrial productivity, product quality improvement, or it could be a productivity into agricultural field. It could be the longevity of the produce of the agricultural produce. Anything. There could be many areas where it can be thought over, and largely it can combine somewhere. Say for example, if the large area is, when we work on certain small areas and then convert it into topic at the end of the day. Suppose it is for the protection of the fruits or the conversion of the fruits, or protection of something like grains. So what I am trying to do is I am trying to contribute to the larger goal of food security of the country, where you have more than 20% of the population of the world is residing. And we have to, and the land available is 2.5% of the world's land, cultivation land. So with this, we have to achieve improve the food security in the country. That is my larger purpose. That is my larger topic. I am just trying to do one part of it somewhere, but I must understand what is the larger purpose which can be assigned. So this is what the explanation I can give for how it can be done. Now, let's understand a few more aspects of the research. How do we, once we decide that the purpose of the research is what is the area in which we are working, then we start writing the projects. It could be the small project written within the laboratory, or it could be the research project which we are bidding to the funding agencies. And for that, we work on certain aspects of research areas and the research methodology which we select. And then what we start working on is how we are going to prove, what are the aims and objectives with how we are going to achieve them. So there are 8 core characteristics that all research projects should have. These 8 core characteristics which I can say is, first is empirical. Empirical is something which is based on the proven scientific methods which are derived from previous experiments or real life observations. So empirical is something where you are having something previously done and you are trying to use the same methodology to find out what happens with your area, your project. In your project, what is going to happen. So the empirical research characteristic is the first research characteristics you work. Second characteristic which we need to work on is logical. As logical is logical. When you want to follow a sequence, you want to follow a sequence for, say for example, I given an example of nanomaterials. So nanomaterials is, first of all, it would start with the finding out how people have synthesized the nanomaterials. So that is the empirical data which you collect. That is the previous experiences, previous experiments, this experimental data you collect. And you select one of this methodology to create your own material. And when you create your own material, then you are going to go for the characterization of it. And once you find that it is, if it is worth that it is what you targeted has been achieved, then fine. Otherwise, you have to go back again to the synthesis procedures, modification of the synthesis procedure. Something went wrong over there, you have to correct it, and then come back again for the characterization. So when you put this kind of sequence to the process on some valid principles, this is what is called the logical characteristics of a research project. So you have to have a logical characteristics. And then within this, I also said about one thing: if you have not achieved your required or desired outcome as a nanomaterial, then probably you will have to go back again to the synthesis and find out what went wrong. So the other characteristic, the third characteristics for the research project is cyclic. That means research begins with a questions and ends with a question, whether it has started, whether we have done the correct thing. So that's one thing. And second idea of this cyclic research is you create another lead for the new line of questioning, new line of research within this. So this is a cyclic, or I would say continuity as well, but as well as cyclic means it's a question and answer, therefore it is cyclic. So this is the third characteristic of any research project. The fourth characteristics of the research project is it could be there could be various aspects, like when you design the experiments. We are going to take this on 21st, the design of experiments. This is going to be interesting to find out how the design of experiments is worked and how you can be sure that this number of experiments will sufficient to derive some logical conclusions out of your data. So when you select some kind of variables for identification, there are a lot of control experiments has to be also done. lot of blank experiments has also to be done. So that characteristics has to be included. Say, for example, if I say that when I use this nanomaterial, a particular reaction is more efficiently happening. If I want to prove that, I'll have to also do a reaction where these materials are not in a nano form or this material are not present. Such kind of blank reactions need to be considered. If within the blank reactions also I get the same data, then probably it's not contribution of my material. It is something else. And if I can prove that in the blank I do not get the same data, then I can safely say that when you put this material, if this is present over there as a catalyst, then only this reaction happens. Before that, that reaction doesn't happen. So as simple as that, you have to have a lot of control experiments as well. And these control experiments or the blank experiments has to be planned. If they are not planned before, this is the kind of the fourth research characteristic which we need to work on and we need to decide before we start the experiments. Then it comes how do we design the data generation? How do we design the data generation? So data generation is designed on the hypothesis-based things. So you have to have a hypothesis at every point of time, not a single hypothesis as a larger hypothesis, but at every point of time, like I was saying, putting up this material into the reaction works as a catalyst and improves the efficiency of the reaction. That's an hypothesis. So you'll have to create certain hypotheses and prove or disprove both, either prove or disprove the hypothesis. And if that happens, then you are probably working in a correct direction. So you create a lot of hypotheses in between, and this is hypothesis-based characteristics of projects. Then comes analytical. Analytical is something which you generate the data, and here also a lot of things are to be considered. Again, I will bring back the experience of mine from the Japanese lab, where we used to put a lot of time and efforts in calibrating our instruments. Because whatever I can measure something on some instrument, but whether what I measured was correct, whether it can be reproduced if it is measured 100 times, that has to be identified. And how do we ensure that? We ensure that with a lot of, calibrations of the systems, calibrations of the method, validations of those methods. And if we don't do, then the possibility of errors is enormous. And whatever the data you have collected might be the absolutely wrong data. I'll give the example of one of the researcher in one of the laboratories. I don't name the laboratory because I don't want to talk the bad things about somebody. But this is important. What was happening was there was some experiment being done. They were collecting some gases from the atmosphere or gases from some gas mixture by adsorption method, and trying to evaluate the materials for the adsorption, gases adsorption. What has happened was they have created a tubular kind of reactor in which the material was filled, and the required gas as a 100% gas was passed through this tube for a certain period of time, fixed period of time, say for 1 hour, and then it was stopped. That gas flow was stopped, and then this reactor was put up for the heating, and desorption occurs, and whatever getting dissolved was collected as a gas sample and was analyzed on GC, gas chromatograph, to identify what is the concentration. Now, every time you are giving the 100% of a gas, which is under consideration on adsorption. So how does it make a difference? Because when it comes outside, what is happening is you are taking a particular amount, a particular microliters of micromilliliter or milliliters or microliters of a gas sample and injecting it into the GC, which is going to give you the peak for those many of microliters of that much of a volume of the gas, volume of the samples which is injected into the gas chromatograph. Every time it remains the same, 100% of that gas. So the error which has been there for collecting and injecting, that error is giving you the difference. Not that actually there is a difference in the adsorption of the gases. So the experiment, the design itself went absolutely wrong. So when that particular student in one of the institutions, one of the university has come to me and discussed, why I am not getting the large differences. So I said, I am surprised you are getting the differences, first of all. If you have been doing it very meticulously, you should not get any difference. Because what you are doing is you are temporarily storing that gas for a particular amount of time, then releasing it. Before it also it was 100% gas, after it was also 100% gas, and of the 100% concentration of the gas, you are putting the same amount of sample at every time, and you are saying that you are getting a difference. Something is terribly wrong. Not that you are not evaluating the material itself, but also your method, there is something, some manual error is there, or there is an error in the GC also there. Something is wrong here. So actually we redesigned that entire experiment. We redesigned that entire experiment. And this person was about to write a paper on it also. He said, forget about writing the paper. You have to do the experiment correctly. So the another part is, how do we analytically do the experiments? Analytical part is very, very important. Whether these techniques are proven, whether they have high efficiency, which you would like to see, whether they are calibrated for that efficiencies. Say, for example, if you want to measure the concentration of something in the water at various levels, it could be concentration in ppm, parts per million, or it could be ppb, parts per billion. If that is a low concentration, whether you really have a technique, whether you have really have the instruments to identify whether it has the ppb level you can measure, and that too with the high efficiency, high accuracy. Then second is whether you can repeat this, how many times you repeat. Repeatability of the experiments is very, very important. And otherwise what will happen? There may be some anomalies in the data. Somewhere some data may be very high values, somewhere some may be very low values. And in such cases, you probably may result into getting actually the erroneous result. It is not that you are getting the out of the box. So most of the time what people do is, if it is not fitting into the general trend, they delete that data. They forget that data. So anomalies in the data might be, we will see in the next session, anomalies in the data sometimes are actually leading to the actual innovations. But we need to identify whether it's a real anomaly of the data or whether it is just an error which is creating that this is exceptional outcome of the data, exceptional outcome is coming. So we need to find out that whether this is exceptional outcome. So this analytical technique, I'm giving a lot of emphasis on the analytical things, is very important. This is very important. So that's one, that's the analytical thing. Then comes the objectives. Objectives is whether what kind of judgment you can take from this data, what kind of leads you can take from this data which you are supposed to create. So once you fit everything, then only the objective kind of things comes. Objective, research objective you may write at the beginning, aims and objectives you write at the beginning. But once you have collected the data, you are going to do some treatment of this data, some analysis of this data, and draw some inferences. To draw such inferences, you need to find out whether what kind of objectives you are going to put. And this, what you can do is with something which ensures that the findings would be unambiguous. There should not be any ambiguity into the kind of findings which we are going to say. It cannot be either way. It should be a single clear-cut outcome which is coming as a research finding. And the last one, the last or the eighth characteristics, there could be many more characteristics, these which I thought are important and therefore I'm putting forward. But the last one is the statistical treatment or mathematical treatment. Either it could be statistical treatment, it could be mathematical treatment, whether you put this into some modeling also. So those kind of treatment given to the data, which is available and which transform into some meaningful knowledge, which transform into some meaningful equations, which transform into some meaningful rules, which can be taken as a basis for the analysis for the when somebody is his own research project. The first characteristic of empirical, where he has to look at the very existing one, has to work on it. So this is what is important, and where we can we can find out whether the statistical treatment or the mathematical treatment can result into meaningful transformation of the data into some knowledge base which we can create. So these are the 8 characteristics which we need to plan, and of course which we need to plan much before we start the research project. So the first thing which I was trying to tell was we have to work on purposeful research. So how do we do the purposeful research? And we do not worry about the topic at the beginning. We work on the purpose and the area. And to write or to plan your research, these are the 8 categories. Now, it's always not the applied research or it's not the application which is always would be coming. The research has another objective also, which is the basic research. Basic research is equally important because unless there is a basic research, there cannot be a very strong scientific basis which can be created. So applied research, when you do the applied research, you are talking about the things which I have explained before, like productivity in some area, like you are talking about product quality improvement, such kind of things, or the direct benefit to the society. Such kind of things comes into the applied research. Applied research is investigated based on the known theories and the principles. So you are not changing the basic theories or the basic principles that are known before, and you are making the use of it to generate your data, analyze your data, or to enhance the knowledge around the practical aim which we have to enhance the knowledge about. And this is because it's a real-time, it's a kind of applied research. It focuses on solving the real-life problems, which can be this research can be applied as an immediate application to this kind of real-life problems. So this is what is important when you look at say again I come back to the suppose some material development. Then the strength of the material would be important if you're looking at making a car body or a vehicle body in that sense. So or a part, bone part of which can be fixed into your bone replacement operations. So where it is, we consider that the application point of view. If the application is known, then what are the attributes or what are the qualities for the particular material has to be there. It has to be considered before. So it is focused. We are not changing anything which is focused on the real life issues. Whereas the basic research, which is something which is you are trying to find out or trying to examine the theories and the principles and trying to change the theories and the principle on the basics of the science, going back to whether this has really said what was investigated before is correct. And many times this basic research may not go to the commercial application, may not go from the lab to land, because the purpose of the basic research may not be the going to the lab to land, but going more deeper, finding the new insights which can be later used for the applied research. So the basic research when we are looking at it is something which is we need to think of in a completely different way than applied research. So here it is more specific and more focus is on the principles and the theories, and going deeper and deeper, trying to understand what exactly the phenomena must have been happening. So if I bring back again the experience from the catalysis, then understanding how the catalysis phenomena is occurring on the interface of the catalyst and the reactant is more important into the basic research than what kind of conversion efficiencies and the improvement in the efficiency of the reactions are occurring. You don't worry about the efficiencies in basic research. Efficiencies will come at a later point of time. In the basic research, your focus has to be how that interaction between the catalyst and the reactant is happening. What is instrumental? What is the reason for that interaction? What extent that interaction can change by changing certain kind of experimental conditions? So such kind of things are important in terms of basic research. So this is a difference between the basic research and the applied research, which we need to focus. Many times the new researchers get confused because even the funding agencies confuses the researchers. If you have submitted a proposal for the basic research, there may be some or other person who may be asking whether it will be the cost-effective application. We're not talking about the application itself in the first place. So whether it is a cost-effective or not, that we will see later. Yes, of course, it is important. It has to be cost-effective. The question is right in that sense, but it is not right in the sense that the purpose of entire that research work is not proving the cost effectiveness, but it is to investigate the deep insight into what is the phenomena which is occurring as a basic principles, and therefore the basic research. So for the basic research, you can't ask applied questions. And similarly, in the reverse, you cannot say that whether you will be establishing a phenomena or a basic principles in the applied research. Applied research is more important in terms of deliverables, in terms of immediate applications, and therefore that is what we should be worried about. The last point in this particular lecture, which I want to emphasize, is on the difference between qualitative and quantitative research. So many times, because when we are talking about, most of us are joined from science and engineering and technology background. So for us, qualitative research actually does not exist. We have most of the things as a quantitative research only. But the qualitative research also exists in certain parts, and in some cases, we need to also, even the scientific research has to collaborate with something on the social aspects. And while the social aspect comes, it is more or less a qualitative questions are generated, and you try to find out qualitative methods. In this case, it is largely depending upon, like this data is collected, many times a non-numerical data also. It could be just a logical data, answers to the interviews or the data which is collected from the case studies. So such kind of data is like a qualitative data, which is being collected. And the qualitative data may not have the fixed parameters. It may change depending upon the focus group which you are talking about. Even when suppose, for example, in case of the applied research, if you go and ask to people, Henry Ford has written this very wonderfully. Henry Ford, who we all know was the first one to manufacture the motor cars. And when he wrote that, if I would have done the qualitative analysis of what people needs as an improvement for the transportation methods, at that particular point of time, when the horses were used for transportation, and if Henry Ford written, if it asked to the people would have demanded faster horses, not the motor cars, because the motor cars were beyond imagination at that point of time. Even today, if the same question is asked, people will ask more safer and faster cars. We are not thinking beyond what we are having available with us. So the constraints may come. There could be the data which would be not very based on the principles, which may not be, even the ambitions would not be there. That is what is the qualitative research, but the qualitative research is also important in terms of understanding what society thinks about this kind of the field which you are targeting to work, which you are targeting to spend your time and efforts. So that is what is important. Then comes the quantitative research and quantitative research, which we all are knowing that we work on the variables, dependent variables, independent variables, particularly particularly relationship between the or relationship of dependent variables on the independent variables, such kind of thing, cause-effect relationships, which we work a large way. So this is what we do most of the times. So when we do the quantitative research also, nowadays there are various methods which are in between as well. So there are principles which one can use. When we do the quantitative research, our approach is of the reductionist approach. You reduce the problems, you break the problems into several problems, and you try to solve such problems one by one. And say, for example, effect of the concentration, effect of the temperature, effect of the flow rate. So at a time, one parameter change. So such kind of break which we create, and we do a reductionist approach to the research. This reductionist approach, which we when use, is a sort of a, in general terms, we can call it as a Newtonian approach towards the research, towards the data collections, towards understanding the cause-effect relationship, towards generating a larger perspective out of it based on the data which we have collected. And this requires a large number of experiments, and still you may not find certain things, or you may have the biases included before. The another approach which is taken care of as of today, which is very common, is we commonly have been hearing and also using. Many of us have started using it in a different way. Is artificial intelligence. We started using artificial intelligence using neural network kind of techniques long back, and then the fuzzy logic came, and today it is more data-driven analysis of the research data, and it is left to the data to evolve. It's left to the data to evolve or uncover the relationship, cause-effect relationship. We don't fix it into some kind of equations in the before. So it's a data-driven. The data requirement into the data-driven analysis is too large. So that's the constraint which is there. But nevertheless, if you are able to collect a large amount of data, it is going to be the more realistic. Because one of the attributes or one of the characteristics of the research project, which I said was a statistical treatment or the mathematical treatment. What happens is generally, when I also had some experiences of working into mathematical modeling, the model which we start planning for the fitting a mathematical equation to a chemical or a physical phenomena, what we do is we take the basic principles and try to fit a mathematical equation. So so firstly, the plan is to go to the real situation. Then we realize it's too complex to go to the real situation. So we start analyzing certain things like the homogeneity of a media, so that the density remains the constant everywhere, or some other density and the viscosity remains the constant everywhere. So this kind of example I'm giving. So we start putting some assumptions to at the planning stage itself, because we cannot write the mathematical equation and solve the mathematical equations, which is very, very real type of thing. It will become too complex equation. It will become too complex to solve. There will be multiple equations which will be created. So there is a limit of the equations which we can handle simultaneously, and there may be a lot of time which will be required to actually generate. So what happens is, from planning to writing the equations and to the solving, there are certain assumptions made to simplify and to make life easy. Okay, so actually you are not getting the real cause-effect relationship. You are not uncovering those relationship between the independent variable and dependent variable in the realistic manner. Whereas data driven, when it is left to data to evolve, it's largely the possibility that you are going to get exactly what is going to come out of as a relationship between various parameters. And therefore, the artificial intelligence is gaining so much of importance as of today. So much of importance it is getting into neural networks has got importance into pharmaceutical fields, because neural network can possibly generate certain relationships which are synoptic relationship between the data which are required depending on the conditions, which can probably uncover certain areas which has not been experienced before. So unforeseen formulations into medical things can also be evolved using the neural network. So neural network has gained a lot of importance in the pharmaceutical industries. Similarly, AI is getting a lot of importance into health, particularly diagnostics. You might have heard even some of the IITs has reported, based on the X-ray image analysis, they have generated AI algorithms which would analyze the COVID-19 infections. First of all, whether it's infected, not infected, and to what extent. So this kind of data analysis, which was image processing, which is not like very quantitative data, it is still a image processing data, which still has some structured data, and a large amount of data could lead to the correct diagnostics of the patient. For the next patient, if you take an X-ray and it just done, you can, based on the previous lot of data which has been used for the learning purpose, can reveal the diagnosis. So these kind of various aspects of the research which has to be there. I think we have a break at 11:30. But just one more point I will just put up, and if you have any questions, we will answer that, and then we will go to the next session after a break. So the last point which I want to put it is, how do we select the purpose, even if we are talking about applied research. So look around you, try to understand the problems which you face, and try to find out whether you can do some improvement. Just and give an example. You know the Bose speakers are the very efficient or the very effective speakers, or very you say most desired speakers as on today. So this Bose was a person basically. He had a habit of listening radio for hours together. But that time, the kind of speakers radio had and the kind of signaling which had, there used to be a lot of noise. So it was not wonderful to have such a noise when you are listening to the music. And he thought, if somebody can give me a noiseless speaker, that would be a very great idea. And he was thinking on. Then he thought, why not I work on it? Why don't I create a speaker which is noiseless speaker? And therefore, the Bose speakers has born. The research, which was initiated by a need of listening to a good music without noise. So if you look around yourself also, you'll find many applied areas or many areas where you need to work on, you need to have an improvement. And this is endless. You try to find out and you'll find there are unlimited areas in which the improvement is required, or the quality of the life has to be improved. So there's no dearth of finding out the research areas and then work on this research area, and the topic can be selected at the end of the day. So I will stop here for this particular session. If you have any questions, I would be pleased to answer those. And we'll take a break of, I don't know how much of the break is defined here. It is 12 noon, we will start again. But
30-minute break.
Yeah. So if there are any questions, I think it has to be put in question answer chat box, or we can put it in the question answer chat box, because it will not create chaos.
So I request participant to interact. So put questions. So there are two hands are raised. So one is Krishna Yadav and Sweta Jha. Krishna Yadav, you can unmute yourself and you can ask questions. Krishna Yadav.
Meantime, there are two questions in the chat box also. So I will answer those. First is to how to formulate research hypothesis. So hypothesis is something which you are planning to have. The hypothesis is very simple. Say, for example, I will take the example which I spoke in this lecture itself. Suppose you are generating a particular medicine, a tablet medicine, and this tablet has a the purpose of this tablet is to cure the cancer. Okay. Just say that, and the hypothesis could be the certain amount of this particular tablet given to the patient at a particular frequency for a particular period of time will cure such kind of cancer at this stage. This could be the hypothesis. Okay. Very precise hypothesis would be this. And the null hypothesis would be this particular tablet is not good more than the sugar candy. So the hypothesis also has, when you write a hypothesis, you have to have a null hypothesis also. So the first hypothesis which we said is this tablet will cure the cancer for a patient at a particular stage if given in a particular quantity at a particular frequency for a particular period. Okay. This is what is the hypothesis. The second question is, what is the difference between empirical and applied research? So applied research can also be done empirically. Empirical is a method and applied is the area. Empirical research is generally based on finding out the cause-effect relationship, which is based on the previous data. Say, for example, if I fit that into some equation which are previously, say, for example, adsorption isotherms. If I collect the data on adsorption and I fit it into the adsorption isotope data, line mode, friendly. So this is something which is empirical. Or and then I prove that the parameters which are given into these equations are also fitting to me either into Langmuir or the friendly, and then I decide based on what kind of phenomena must have been occurring during my experiment. So this is empirical. Applied is which has got the application, which has got the applications in there. We are not talking about the basics, which I explained. So, for example, I am not talking about the phenomena or the mechanism of the reaction which is occurring. I am talking about the efficiency of the reaction. So, efficiency of the reaction is applied research. How neural network data can be used in the research. Okay, neural network is not the data. Neural network is again a technique. Not neural network data is available. There is no such thing called neural network data available. What you are doing is you are using the neural network. What neural network does? How does the neural network works? Neural network works on the basis of the principles of formulating certain artificial neurons, which are nothing but the mathematical functions, which are either transform some previous data, which are input data into an output data and take certain decisions. This is what is artificial neural network. The actual neural network, what it does is, what is actually a neural network does in your mind is, you have a lot of millions of neurons, and these neurons, they can chemically or synaptic, they are connected synaptically, and they transform the electronic signals to each other. The signals are transformed to each other in the forms of binary, like either they say yes or no. There is no in between. So, say for example, if you touch a hot surface, your sensory organs on your fingertips will sense a temperature and will send the signals to mind saying that this is hot. So neurons collectively, millions of neurons participate into this, and they collectively analyze the situation, pass yes or no, and a particular pattern is created, which is your learning process in the mind, that you actually get into that this is hot. So the next time, then another sensory organ of yours, the eye, which sees a hot surface, because it has also seen by the eye that time when you touched. So you don't realize that for you it's a sensory organ is at that particular time when you had that heat shock was your fingertips, but your eyes has also seen that. So what happens is next time the data which is collected by the eyes of the surface, it's how the surface looks like, brain analyzes and says that it's a hot surface, do not touch it. So it's a very simple way the neurons are working. Similarly, those mathematical functions which is created can be given weight and biases also for their decision-making process, and they can get that data. So you have a lot of data first, then the relationship is created and output data is created based on this data. So there is a neural network method. There is no neural network data.
There are 3 questions.
Yeah, there are a few questions. So somebody said not audible in between, but anyhow.
No, somebody asked, Utpal Das asked questions. If I want to join a PhD program now after 1 year, shall I need one to select the topic or the research area of research? Something.
So I think my lecture was not fruitful, but still you are thinking of this either selecting topic or the research area. I think it was not impactful enough. To me, the area of research is important, not the topic. Topic here will be at the end of the day. So Utpal, I can help you out. If you require, it can be personal level also, I can help you out. But please go to the research, not the topic. Might be the university or the institution which you are planning to register might ask you to register the topic itself. That may be the requirement there. But while doing so also, please work for 6 months on the research area and then decide the topic. Don't go for the topic at the beginning. I have seen that most of the Indian theses are so big, but the foreign theses are not huge as Indian. Why so? It's very simple reason, Utpal, again, because when you don't have a very specific data, very specific outcome, you would like to show many other things. You are not focused, and therefore thesis becomes very bulky. I wanted to write a thesis which I could not do because it requires a lot of efforts. I wanted to finish off my thesis in 25 pages. It went more than 100 pages actually. So I did not like my own thesis, which run more than 100 pages, which I wanted to finish off in within 25. Because it's very difficult to write impactful in very less amount of pages. There is one journal in chemical sciences, which is called ChemCom, Chemical Communications. And the ChemCom has two big constants. There's a page limit. You cannot write a paper more than 2 pages, for one. And second is the abstract has to be single line abstract, single statement abstract. You try to write a single statement abstract to any paper, it's extremely difficult. If you can do that, that means you understood what you did. You have understood the purpose. So the big theses are not good. They are basically because you are not able to put everything very logically. So to me, the good thesis would be 25 pages.
Many IEEE journals also, journals and conference, they put limit on pages, a 6-page or 8-page limit.
Yes. So this ChemCom is very typical. It's a 2 pages only.
Yeah, that's
very
great.
difficult, right? 2 pages, writing 2 pages is very difficult.
In mathematics, one of the journals, on highly cited one paper is actually, it is 2-page journals in mathematics.
Yeah, and I can give you one example. I can quote. There is a paper by Koros and Novak, which actually identifies whether you are in a kinetic regime or a mass transfer regime in a chemical engineering experiments. This paper is less than a 1 page. They did not complete the page. It's published, thoroughly used.
So I believe no more questions.
Statistical and mathematical treatment I have already spoke about again. I have repeated it also. And what was the third characteristics? The third characteristic was the cyclic nature of the project data, which start with the question, ends with the question, so that you generate a new questions for new research. It's not that you have found everything and you close that topic. It cannot happen. You have to create the new line of the questions in that area. Then only you have actually done the research. You have see it's the same as, if I can give an example. If you have ever climbed any hills, if you climb one hill, while climbing, you feel that that's the apex of the hill which you are seeing is the target you have to reach. That's the hill. Okay, that's the highest hill. Once you reach there, you find that there are 3 more hills ahead of you, which are much higher than this. You start climbing, then you'll find another one. It's expanding the horizon. It's expanding horizon and then expanding your vision of that area. So if you have expanded, you will generate more questions. Not that you found everything on that research area and you close that area forever. So that doesn't happen.
I think all questions have been answered. I think so.
Yeah.
Okay. Thank you, Rajesh ji. So we'll again meet at 12 noon. So we have a break of around 19 minutes.
And I would request all of you to be interactive. This is wonderful that you have said so many questions. That means you're worried about.
They can ask maybe. They can put in the chat box. During the session also they can put in chat box maybe.
Yes, of course. That is very easy to answer from reading from the chat box and answer. Right. Okay, so we can have a break now.
Okay.
Enjoy. I think the same link will work, or for me, or what?
I think the same link.
Sir, same link will work, sir.
Okay.
Yes.
So we'll meet at 12.
Yeah, sure.
Hello.
Yeah, hello.
Hello, Rajesh Bhai sir. So, are you ready?
I'm ready. And you can just allow me to share the content. This time I'm going to use the slides.
Someone have already. Okay.
No, I just logged it out, so it's got this now displayable.
Okay.
Already enable it again, please. I did not keep the same session. Yeah, now it's good.
Okay. Hello, host. Who is the host? Firoja, madam?
Yes, sir. Yes, sir. Yes, sir. I didn't get sir's issue.
Yeah, please allow Rajesh sir to say.
It is allowed now.
Yes, yes. Sir,
Yeah,
I have made you the presenter.
yeah, it's already there.
Sir, you can start with the session.
Yeah, have enough participants.
Yeah, 120 participants. Sir. Almost all are on increasing. Slowly, people are joining again.
Yeah, sure. So I can start.
Yeah.
So this second session, which my slides are visible. It's
Visible.
Yeah. The second session, which we are now going to talk, is all about identifying the research areas. Let me put my video off because everything.
Sir, it's done, sir. Your video is off now.
Right, correct. You did it. Okay, fine. Thank you. Because my bandwidth is not supporting the entire thing, so
Yes, sir.
there's too much of bandwidth on the video. Okay. So we are talking about identifying the research priorities and the plan of action. So my first point over here is to okay. The first point over here is to talk about the kind of benevolent research which we want to do, which everybody should be working on the benevolent research. And these are the examples which are taken by very successful researchers, but they have a different set of research ideas, different set mindsets, and therefore their research, although very successful research in terms of findings, in terms of applicability, there are certain things which are different, very different in both of them. The one example which I'm just putting a set, I'm putting this context for you to set tone in which we want to do the research. So this is Thomas Mingle, who was a UK, he was from UK. Thomas Mingle was a very successful researcher having more than 100 patents. And most of the time he was working for a kind of a sponsored research from different companies. The big American companies used to sponsor him the research and he used to work on it. A lot of new chemicals, a lot of new methods he had generated. And he was working mostly on chemical sciences. So two important chemicals which he has created at that point of time, but now has got issue, is one is tetraethyl lead, which is added into the gasoline to make the engine smooth. It has got an anti-knocking property. Anti-knocking means if the piston does not move completely into the cylinder of the engine, then it is called knocking. And if the knocking occurs, you don't get the good efficiency of the engine out of fuel burning. So tetraethyl lead was having a good anti-knocking property, and it actually improved the IC engine's performance like anything. However, the tetraethyl lead was adding lead into the gasoline, and this lead is coming out from the exhaust emissions of the engines. And this has now created the lead deposits across the world because leaded gasoline was used. And the lead has a direct impact on your nervous system, and particularly younger and elders are more vulnerable to this particular lead. So the tetraethyl lead, which was giving a good functioning to IC engine, has actually emitted lead in the atmosphere. The worst part of this entire story is the lead is so stable in the atmosphere that to undo this effect of these lead emissions, which has occurred over a period of more than 100 years now, you will need another at least 50, 70 years to undo, out of which maybe 10, 15 years has already gone because lead has been banned into various countries, the gasoline now. So, although very good in terms of IC engines improvement, this has got a very bad effect on the environment and the health. Another compound, I'm just giving you the two examples from this research, is chlorofluorocarbon. We all know the chlorofluorocarbons were very good refrigerating agents, and therefore you could start doing refrigerations in those areas, right, on those periods. Wonderful as far as refrigeration is concerned, but the chlorofluorocarbon has got an hit, the ozone layer in the atmosphere, and we had ozone hole formation, which removed the protection from the UV light, UV which is coming from sun. So you have a very, very big problem of the ozone hole because of the CFCs being used as a refrigerant. The research was good, but at the same time, the refrigeration, point of refrigeration is good for those heat cycles, it was good, but then it has got a very bad effect on the environment. Fortunately enough, ozone hole is getting repaired because CFCs were banned again, and ozone hole is getting repaired now because there are no more CFCs, there are no more chain reactions occurring over there for the destruction of ozone, and it's covered. As compared to that, Masanobu Fukuoka, a Japanese researcher in the agriculture field, he has developed one very good variety of rice. It was so good that particularly there was a large demand for his rice, and it was unique to him. So in fact, I think he took IPR also. I'm not sure whether this was done, but he took the IPR on it as well. But he started distributing the kind of seeds or the kind of samplings of this rice paddies to surrounding farmers. Now, somebody reached him commercially that we would like to buy these commercial rights for this particular variety of rice, but the condition is you should not distribute it free of cost to the other farmers. So he said that's not possible. Then these people tried to convince him, why you are killing yourself? Because if you distribute freely, everybody will use it. Then he said, if I want to maintain the quality of rice in my field, I need to ensure the cross-pollination from the correct variety of the rice or the similar or the same good variety of the rice across the fields. So to my survival itself, it is very important that others should also plant the same kind of rice. Others should also put the same kind of rice so that the cross-pollination becomes a good thing for me. So this is a kind of, there is a book written by him, One Straw Revolution. You must read this book. One Straw Revolution actually tells you how do you how do you develop the ecosystem around it. And the entire ecosystem balancing the growth of every stakeholder of the ecosystem. So while doing the research is a two-edged sword. It can cut others, it can cut you as well. So to us, what we feel is, it is something like what we always say, like everybody has to be, it should benefit to everybody. And therefore, this is the research attitude which we want to take. Okay. So societal benefits is an important, industrial benefits is also important, but what is important is it is a benevolent research. Okay. Having said that, I'm coming to the point now where we want to work on rigorness of the research. And while doing the rigorness of the research, there are certain stumbling blocks where you can probably stumble, you can have some hurdles in between, or you can miss certain things. So I call them not misleads, but the missed leads, the leads which you missed during the rushing of your research. So one of them is the serendipity. Serendipity is a preparedness of a mind, which is important. You might come when I was speaking in the previous session, I was talking about the anomalies of the data. Anomalies of the data need to be understood correctly. And first of all, whether there are real anomalies or whether there are errors. But if at all there are not errors, they are real anomalies, then there is a likely that serendipity can occur. Serendipity is something which is coming in front of you unheard before, unnoticed before, and you suddenly get that kind of data, that kind of analysis, and then that kind of findings which we need to convert into a fruitful, purposeful kind of outcome of the research. So for the serendipity, preparedness of the mind is very important. I'll give you the examples of how it can happen and how one can be ready with the preparedness of the mind. Second is depth versus hurry. You might have a targets also. You might have a targets. In some cases, you might have a targets. In some cases, you might have no targets, no time targets, but you can go into deeper and deeper. This happens. I'll give the examples of this also. How does it happens? But depth versus hurry is also an important aspect where you might miss the leads which are there into your research. When you are trying, you are collecting the data, you need to worry. Then sharpening of the tools, which I already spoken, that what is the why tools need to be sharpened. The example which I gave was the calibration. We'll speak more on this calibration. Okay, how does this matters? And also need to understand that we are the piece of a jigsaw puzzle. Okay, if you understand that you are a piece of a jigsaw puzzle and which piece you are, you will probably be able to complete the picture, which is a larger picture. I'll explain you what does it means. How do you understand whether you are a piece of a jigsaw puzzle? So this is important. We'll go one by one into the detail, and we will identify what are the care to be taken, or what are the methods by which you can understand. Let's go for the serendipity, preparedness of the mind. This is the research which was done for penicillin. Penicillin was not a targeted research. These were the dirty, I'll just take a pointer. These were the dirty petri dishes which were there from the previous some of the experiments. And there was some growth, microbial growth into this. Now, usually we would have cleaned this. This is a very dirty thing, but this was not done. It was analyzed. And it was trying to find out why this growth has occurred over here. And the very important first antibiotic, penicillin, was born. So this was not planned. This was not planned in the research in the laboratory, that you create this growth and you try to analyze this growth and then try to find out why it has been there and how useful it would be to the humankind. But these petri dishes, which were dirty petri dishes, actually resulted into a wonderful drug, which is penicillin. So this was a serendipity. This came as a sudden. This growth came as a sudden. But the mind of the Fleming was prepared to understand, to analyze, was having patience to understand it, and having the wisdom to connect it to the applied research. So therefore, penicillin was born. This is what is the serendipity, understanding of the serendipity for a prepared mind, the mind which is ready to accept, the mind which is ready to understand, the mind which is ready to see that which was not planned, why it has occurred, and analyze, either result into good thing or just discard the things or correct the errors. So serendipity is an important aspect. Second is depth versus hurry. So depth versus hurry, how does we do is something which many times this happens. Before going to the astrophysics examples, I would like to say sometimes you don't have the time for the depth, which we have realized during the vaccine development for the COVID-19. Recent example, you had a time limit. Otherwise, vaccine development would take decades together. You work on certain normal medicines also, they take decades together. So people have developed some rapid kind of testing mechanisms to create that vaccines faster. There are questions raised definitely that if this was not tested enough for a longer enough period, whether they are safe or what. But it was the quest of survival. So the quest of the survival against that virus, and therefore it was this hurry was a needed hurry, that you need to have this vaccine yesterday, and that is what is the hurry in this particular development. So again, this was like the example which was a desperate need of a certain thing. But many times there is no such desperate need, and still people are in hurry. And what happens is missing the signpost. Missing the signpost means you can draw the analogy from driving on the road. There are always a lot of signposts are written that there is a blind spot ahead, or there is an accident prone area ahead, or there is a school ahead, whatever, the sharp turns ahead. These signposts are there. If you are driving too fast, likely that you don't read those, and possibly your driving may not be the safe driving, may not result into you reaching safely at the destination. So the signposts are important. So similar signpost arises during your research. There are signposts which some of the events, particularly in astrophysics, you get a lot of events occur on the universe scale, and there those events you may not be ready for understanding it at point of time. But these are some of the events which will tell you what is happening. So that can happen in the laboratory experiments also. So the missing the signpost is something which is really actually one of the very, I would say, one of the most vulnerable, potentially vulnerable aspect of the research, which we miss many times. So we need to avoid this, missing the signpost to be avoided. Sharpening the tools. It's as simple as that. The picture is shown as sharpening of a knife, which is required for cutting. Unless the edge is sharpened, it won't cut smoothly. Many times it won't cut itself if it is not sharpened enough. So the purpose will be not solved for the knife if it is not sharp. So it's the same thing for your tools, which have to be calibrated. I will go more into the detail, which I spoken about the calibrations before. That unless unless your instruments are calibrated enough and repeatedly calibrated, it's not that once you calibrated, I calibrated instrument 2 years back and I'm still using it. Not done. You will have to calibrate it most of the times periodically. You need to set that periodicity. That in how many experiments or how many months or how many weeks you need to calibrate, that has to be specified based on checking the calibration several times at that intermittent point of time. So you need to worry about planting some of the known samples in between as well. Calibration would be done periodically, but while doing the experiments also, when I spoke in the previous session, I spoke about some blanks. So similarly for the instruments check purpose, you need to plant the known samples also, that whether you get the same data which is expected to get. Therefore, for the experimental data which you are collecting is correct, that what one can understand. So the calibration and intermittent validation of the methods on the instruments which you are using is important in your research. Otherwise, whatever the data you collected, you yourself will not be confident enough. If somebody challenges that if I put this data and try to do certain things into the field, will it work? You have to write a guarantee for it, suppose. Then how much is the confidence you have to write that guarantee? So that is what that will come, that confidence will come from this sharpening of the tools which you are using. So it's not only the calibration, it is intermittent validation is also equally important. Both are the important things. So that is one thing. Second is, I spoke about identifying many times what happens when you use the instrument, whether it is a good, even if it's a good calibrated instrument, everything. But certain values which you get is the beyond detectable limit, because the detectability limit of the instrument itself may be certain, a specified one. And if you have the concentrations in your, suppose some instrument or some chemicals, it's much below that detectable limit, the data only you get is a beyond detectable limit. You don't get the data which is required actually. So you'll have to have instrument which is having much better list counts, much better. Say for example, if I want to measure the length, if I am measuring into inches or the centimeters, a normal scale will do. If am measuring it into millimeters, a slightly proper scale or a vernier scale would be required. But if I want to go beyond below millimeters, a screw gauge would be more important too. So it's a tool which we are going to use for the purpose, for the measurement purpose which we are using, has to be understood well and to be chosen in that way. Otherwise, the data would be, most of the data would be of no use. I'll give one more example. Somebody was discussing with me. Again, this example is again from the adsorption, but this is for the adsorption of removal of cadmium and chromium from the water using some kind of activated carbon. I don't know how many of you have worked on the adsorption, but he was showing me the data which was 95% plus kind of removal of the cadmium and chromium, and he plotted those adsorption isotherms also and compared those adsorption isotherm by least square fitting method to Friendlich, Langmuir and few more isotherms which are in the literature, and trying to explain that data. But what is important is why he was getting 95% removal is because he has added too much of adsorbent as compared to the amount of pollutants which are available in the water in his experiment. Therefore, entire thing was getting removed. Most of the thing was getting removed because a lot of adsorbent. So you have to do the experiment with little amount of adsorbent so that your removal efficiency is not more than 25-30%. Okay. Because the purpose here is not to show that you can remove most of the cadmium chromium, but your purpose is to fit the adsorption isotherm to understand the phenomena, which phenomena is more prevailing, what kind of adsorbent it is, monolayer, multi-layer, whether the adsorbent is a chemical bond, as a physical adsorption or chemical adsorption, whether it is governed by van der Waals forces in the physical adsorption, or whether it's a covalent bonds in the chemical adsorption. So the purpose is this. The purpose is not 95% efficiency. Purpose is you have to find out that actual numbers. So for that, the efficiency has to be as low as 25 to 30%. You should not have an abundant adsorbent over there. Abundant adsorbent will avoid the collection of intermittent point. So this is an example which I am bringing, which is important to understand that. And of course, when you design the column for a certain instrument which will be used for filtration of the water to remove these pollutants, there probably you will need 95% plus removal efficiencies. That's the removal efficiency. That is different and this is different. So you have to sharpen your tools. You have to understand what you are working on and where you are working. The another point, which is a piece of jigsaw puzzle, we need to understand. This is a jigsaw puzzle everybody know. And this particular piece which is lying outside can fit only in the slot which is available over there. So it will fit. Sometimes it could be more complicated like this, a three-dimensional jigsaw puzzle, where it's difficult to understand where it's going to fit. You'll have to understand it many ways. of finding out the colors of those pieces and the colors of the pieces around, and then the kind of the shapes which are allowed to fit in. So drawing the analogy from these jigsaw puzzles, either a kind of a surface jigsaw puzzle or a three-dimensional jigsaw puzzle, what I'm trying to say is over here is you need to understand where your data or your findings will fit into overall picture. We have taken one example where suppose if I am working on the increasing the shelf life of a agricultural produce, a fruit or a grain, then I am actually trying to contribute to a larger picture of the food security of the country. Purpose of my research is not the food security, but I do know that if I do this research and if I come with the findings of improving the shelf life of the material, agricultural produce, food products, probably I am contributing to one of the important aspects of the food security of the country. So this is what is I'm calling it as a piece of a jigsaw puzzle. I'm knowing I'm a piece of a jigsaw puzzle which makes the entire, if we solve it, it makes an entire larger picture like this. So this is also important to understand. I'll give you another example. Suppose there are machines which has a lot of gears, which has a lot of axles, and they move. These gears moves in a particular direction and with a particular speed. If every gear which moves in a given direction and with a given speed which is defined for that gear correctly, then the entire machine will function correctly. Otherwise, it will not. So you will have to understand the way it has to function, the way your findings has to fit in. So this is what I'm talking about, the jigsaw puzzle that we need to understand. So as I said, adsorption capacity versus the rate. I was giving the adsorption example here also. When again I'm just giving this adsorption in terms of say for example removal of the gas, one of the gas from the binary gas mixture by using adsorption. So adsorption capacity is important, but it's not only the parameter. Having the high adsorption capacity, even higher, you start moving from physical adsorption to chemical adsorption so that more and more component of the gas can be adsorbed. That is okay. But the adsorption material, adsorbent, has to be used multiple times. How can you use it multiple times? Once you adsorb, it's a separation process. Adsorption is a separation process. Once you adsorb from a binary mixture, suppose a gas A and B is there, and you adsorb gas A, you will have to give it back. You have to remove it from the adsorption surface and separate it out somewhere else in another cylinder so that A and B is separated. You repeatedly and A and B is separated. So the same adsorbent surface has to be used multiple times. And when can it be multiple times used? When there is an adsorption rate is faster and as well as desorption rate is also faster. So the rates will matter more for multiple time utilization of this surface rather than the capacity. So when you assign a purpose, you will understand how do I do the experiment. And therefore I emphasize on assigning the purpose to the research. What is my purpose? My purpose is separation of binary gas mixture into component A and B separately. Currently they are mixed A and B together. So, and cost effectively, more efficiently, given time, less time. So such kind of purposes, such kind of objectives can be achieved by having the adsorption which adsorb to material which may have a lesser adsorption capacity but higher rates. So it's as well as simply if you want to empty a bucket and you have a kind of mug to empty this bucket, then how faster mugs can move for each batch, it will be more important rather than what capacity of that mug, which is suppose it's a 1 liter mug and you're emptying a 20 liter bucket. 1 liter mug moving one time in a 1 hour would take 20 hours to empty this. Whereas if it moves in 1 second, it will take only 20 seconds to empty this 20 liter. So it's important to understand the capacity versus rates. Now, having said these four aspects, which are sometimes the misleads of the research, I'm moving towards a different perspective which can be given to the research. So these perspectives are in terms of how the perspective is something which is you are seeing from a frame of reference, and within frame of reference, how do you look at it? So this is one of the story, which is a very good story. I'm trying to use the story because I want to explain how the real failures are there any real failures in the experiments and the data. Although I cautioned you before also that while collecting the data, you will have to sure that you are collecting the accurate data. But this 3M story will also tell you if you have collected the correct data and even your hypothesis proved to be wrong, and even if you feel that the experiment was failed, what can happen? 3M is a big company, which is an American company, and they have taken a research project long back, much before, say, maybe 3-4 decades back, for generating a glue, which will be a strong glue, which will fit like anything. Once you have put that glue, nothing can be removed. If it is glued with using this particular strong glue, it will be glued forever. So the research was sponsored, research was made, there were experiments done, the material was created. And the end of the day, what happened was, at the end of the entire project, what happened was, the glue which came out was actually the very weak glue. It could not fix anything. It could not stay glued. It got removed easily. So actually speaking, the purpose was entirely failed. The aim objectives of the research was, aim and objective of the research was to create a glue which is something which is your super glue kind of thing. Now this super glue which failed, so what happened was this was like kept aside, this research was kept aside, but they documented it well and kept aside. After over a period, they found that there is one more application required where you need to have a glue which is easy to remove, will not remain this, will be used for the sticking, but will be removed easily and will not put any stains or any marks on the surface where it has been glued. And therefore, what you see in the picture is your yellow sheets, which you commonly use, which are very easy to stick, very easy to remove, and very temporarily it sticks. So as simple as that, it is very important product which has been created, which has been very well used. But it was from the data which actually has failed that particular project. But the experimental data was correct. Experimental data was right. And therefore, this kind of material could be developed, and this material is useful. Now, let's talk about the data perspective. How you look at the data which you have collected. Given the understanding that you have collected the data accurately, you have checked the repeatability of the data. You have also examined whether the accuracy of the data is with respect to calibration, with respect to blank, is correct. You also understand that what you are doing as a research, as a jigsaw puzzle, everything you understand now. Okay? But then again, the data perspective, how do you look at the data? So this is again example from my own research, and this is very important point where I actually has got a vision to change looking at the data which you get and change the vision to plan the experiment. I'm using the big words, vision, but that's what actually happened on that day with me. This is the data which we collected from the first ever experiment I did in the Japanese lab for the hydrogen production. I was working on the hydrogen as a fuel and some hydrogen production experiments which we are doing. using a pulse spray mechanism reactor, where you have a reactant entered intermittently at a particular frequency and with a pulse. So what is we were getting, what we got was this kind of the data, which is almost, if you plot on the time on series data versus hydrogen rate, what we got is almost many a times it was 0, except that for 3 times on this time scale, it went up, showed some hydrogen and just came down. Here I have not drawn it much properly, but it was a sharp, these were the sharp peaks. That meant it just intermittently went up and came down. It was not like that it was moving up over here and then coming down. It was just intermittently came up and down. So this is the data which was collected. Now, this was sponsored by a Japanese company. So they wanted to come for the review. So by that time, I was in Japan, and as I do I create an experimental setup and do the experiment. This was the only set of the data which I had. And the professor called me that tomorrow we have a review meeting and you have to present the data. I said, I do not have the data except this one. I just showed him. And I don't trust that this data should be presented. You don't have good data available. So he said, whatever is available, just present it. And don't worry about what is available, because this we will see how it looks like, what inferences to be drawn. We will see at the later point of time, but just present whatever is available. Of course, I created a presentation of 6, 7, 10 slides, starting with the introduction, then putting up what other people have done, and how the experimental setup is, description of experimental setup. So not many information which was not of so much of interest, not necessarily to be there, but trying to increase the number of my slides. That's the answer to the question which was asked in the previous session, number of pages in the thesis. So number of the slides which I included was too many. And many of them were not so useful, not required. Calibration curves also we have shown. Yes, calibration has to be done, but not to be included into the presentation. It is your part of the game. It is necessary and mandatory thing. Then only you collect the data. So no need to show the calibration curve to the people that have calibrated it. It is as simple as that. If you are driving, no need to show that when you run, every time you have to show it to others that how you learn the driving. That's a part of the game. That's a part of the game. So, of course, I had only one data to present. So I thought, at least for speaking for 10 minutes, I should have some more slides. And I created those slides. It was the fact-based slides, but then was not so much necessary. So my entire presentation finished in some 8-9 minutes. And this was the last slide which you are seeing was shown. Of course, there were some numbers on the time and on the x-axis and y-axis also, and some units also. But for this purpose, I'm just not bothering you with that data, but just to understand the essence. There was a large discussion which held on this particular slide. Other slide, nobody asked any questions. This slide was kept projected, and almost like 40-45 minutes, people were speaking on this slide. And I was not able to understand because entire discussion was in Japanese. And that time I was not actually having any understanding of the Japanese. So I was not able to understand whether what they are speaking. The only one wondering which I was having in my mind was, what is that so much to discuss 40-45 minutes on this particular data, which is absolutely not a good data. And this is one-time data. So looking at my face after about 40-45 minutes, my professor realized that I am not getting anything from this discussion. So he translated it in English and started saying me that these people are very, very impressed with this data. It's a very impressive data which you have collected, and they are very happy about it and they want to discuss this data further. Now I said, come on, what is that so great about it? So the explanation given was this. The person from the Japanese company said that you have collected the data which is mostly at the 0. Only 3 times it entered into the area which is a desired area for the hydrogen production rate. We are not interested in this area of a 0. definitely. But we are interested in this area, which is now marked here on the slide as a colored box, okay, light green color box. So this is the area in which hydrogen production rate has to be. And in very first experiment, you have reached at least 3 times into this area. Now, only thing which we need to find out the condition on which these particular peaks appeared and keep those conditions continuously in your experiment so that hydrogen rate will not be 0, it will be in this range. It opened up my eyes. It opened up my eyes. Don't look at this 0. This is not of the interest. The interest area of your data and the result is this. Now I need to focus on this area. I need to focus on, I had got it already. So I need to find out when this happened, what was the condition, why this has happened. So if I can create those conditions continuously, I will get the hydrogen production rate, high hydrogen production rate. This is the perspective of looking at the data has to be changed. My perspective got changed on that day. So this is something which I feel that every researcher should look at their own data and find out how are we looking at it and why we are so concerned about the areas where we are having no interest. Most of the time we will feel that I need to work on the what has happened over here, what went wrong, and I need to correct it. No need to correct. You already reached over here. Try to find out why this has happened, and then correct. Then plan your experiments such that these are the only conditions which are prevailing. So this is what the data perspective which I wanted to give. Now, I want to give you something which is important in the thinking process, which is while you get the data and then analyze the data, and then looking at the data, you draw some conclusions. Some findings are created. So to do this, I would like to give you a puzzle. And since we are online mode, otherwise I generally get this puzzle solved by the people. But since we are on the online mode, I just give you 1 or 1.5 minutes only, not more than that, so that we try to solve this puzzle. You can take pen and paper by yourself, try to solve it, and then we will discuss. I'll explain puzzle. So the puzzle is like this. There are 4 points, and these 4 points to be joined by straight lines, 3 straight lines. Okay, 4 points given. You can draw similar 4 points on your paper, and these 4 points to be joined by 3 straight lines only, not 1, 2, not 4, 3 straight lines. Lines has to be straight. And the third condition is figure has to be closed figure. Means where you start should end, closed figure. Okay. I'm just putting 1 minute on my stopwatch, and I'm going to stop for 1 minute just to give you an opportunity to excite your minds so that you can create this, you can participate into the next discussion. I'm just putting on the, I have just put, this is start of my stopwatch. I just start, wait for 1 minute. Time starts now. I'm going to keep mum for this 1 minute. And please try solving this puzzle. I will not be able to see what you are doing because we are doing online and you are not projecting yourself over here. But nevertheless, you will understand once we discuss this. I'll give 1.5 minutes already because half minute has already gone. So So time is up. I'm going to explain it further. So somebody has put up its head into chat box somewhere. If other people want to put, okay, then other people, somebody has got the solution already. So now let's understand what is done. So if you remember, the conditions were all 4 points to be joined. Yes, I'm coming by 3 straight lines, and figure should be a closed figure. So those who have tried like the solution like this is not the solution because it's not a closed figure. It's a Z. This is crossing, again it's not a closed figure, and this is not allowed. So these 4 points are not joined by the 3 straight line. This is also not a closed figure. So if these are the solutions from your side, you're still not thinking deeper. I already have one answer which is correct one. So good work for those who have really done it. I'll tell you what is the solution. Solution is, let's revisit. Let's understand what were the conditions. The conditions were all 4 points to be joined. And second condition was by 3 straight lines. And the third condition was figure should be a closed figure. So these were the 4 points. If I draw like this, start from outside this and then complete my figure. This satisfies all 4 points to be joined only by 3 straight lines, and the figure is a closed figure. So it's possible. It's not that it is impossible. Now, what was the problem when people have thought of this kind of solutions? The problem was people has put one more constraint on their mind, that they have to start from the point which is given. It was not a constraint in the field. These are the only 3 constraints. There was no 4th constraint which was saying that you have to start from the point. You can start outside. And starting this outside is something which otherwise also can be termed as thinking outside the box, out of box thinking. Out of box thinking, if you want to understand, this is one of the example where you don't get constraint, you don't put some constraint on your mind which are not there in the real problem. The problem was very simple. Problem was not having those constraints, and therefore you are not getting the solution because you created your 4th constraint. So once you've finished it, once you remove this 4th constraint, the solution was available and solution was not that difficult. So this is also important in the research. If the constraints which we do not have, we should not be worrying about those things. Okay, now I spoke something about data treatment, either statistical or mathematical, either cause-effect relationship or either going beyond cause-effect relationship or deterministic approach. Deterministic approach is you know how to determine it, how to derive it. But that's a deterministic approach. But beyond deterministic approach, we talked about the neural network and the artificial intelligence. I'm just going to give you some more examples in this. I'm trying to make it more clear in this particular aspect how the fuzzy logics can work. What is fuzzy logics? Fuzzy logics is like this. Suppose if you have a chair, and you collect the data on this chair for your experiment and define this chair. Define this chair, how do I define? I define the chair that a wooden structure or a structure made out of the wood having a plank which is kept horizontal, another plank or a support which is vertical, which gives you support for sitting and support to your back, and is raised by using 4 legs. Okay, let's restrict our definition over here. Now this is what is the chair which we have defined in your area. So this is the deterministic approach. When you want to define the chair next time, you will have to meet those conditions, that it is to be made of the wood, it has to have a planks, one for sitting, one for vertical support, and it is to be raised by 4 legs, at a particular height. So this is the definition. This is the deterministic approach to the problem. But suppose you have been trained by showing this chair. A human has been trained by showing this chair, that this is how the chair looks like. And a computer has been also trained by showing this chair. Then you have been taken to some other places where there is some structure like this is kept, which is also useful for sitting, which is also very comfortable, okay, but does not fit into any definition of the chair which was here. There is nothing, there is no wooden things, there are no two planks at right angle to each other, one horizontal, one vertical. There are no four legs which are supporting, but still a human being, if a question is asked, whether this is a chair, human being will say, yes, this is a chair. At the most, human will say, yes, probably it can also be called as a chair. Okay. Although you have never seen this before and your definition was restricted to this, but the computer will reject this as a chair because it does not fit into the definition of the chair which was given to computer, which is more deterministic approach of a computer. So the area which is not well defined for the definition purpose is called fuzzy area. And the logics which defines this, how much you can go beyond, how much you can expand your uncertainties, that is what is called the fuzzy logics. So fuzzy logics is something which is being used for creating the artificial intelligence also. How much you can differ. Of course, you cannot differ like anything, but still some parameters you can differ. Which parameters you can differ, by what extent. So this is how the intelligence is being used and the artificial intelligence is created. Okay. So this is the fuzzy logic on your data. I'm trying to give you the different perspectives of understanding the data, different perspectives of analyzing the data, which I spoke in the previous session. Now, what is the application? You might have heard that your normal washing machines used in a home many times use the fuzzy logics. What do you mean by fuzzy logics? The meaning of the fuzzy logics over here is they adjust their speed, they adjust their duration, they adjust their sequences in such a way, the way you upload the clothes into the machine, you upload the kind of variety of the clothes into the machine. Based on the weights it can analyze, based on the weights and the weight and the volume it can analyze, and it can decide how to wash this. Okay. Not every time you have a fixed thing, that the 3 cotton shirts, 2 terracotta pants, and that's it what you want to put into the washing machine, and then only washing machine will work. It's not that fixed and deterministic. It is moved more towards the fuzzy logics. So this is what another example or another aspect which I want to cover is again similar, which is again to the out of box thinking kind of thing. But whether the nano size make a big change, that's the title which I given to this slide, which I am going to show you what do you mean by this. Why the new areas of the research can be, how the new areas of the research can be identified on how they can work. So this is a triangle, which is a decision triangle. When we develop some new catalyst for a particular reactions, so what we do is we find out the reaction conditions on which temperature, at what pressure, at what velocities the reactor should enter into the system. All those are the reaction conditions. Then comes the catalyst, because I am talking about the catalyst right now, just giving example from the catalyst field. The catalyst formula is important. What kind of catalyst? Is it a metallic catalyst? Is it a metal oxide? It is, if it is a metal, whether it is a single metal, whether it is a bimetallic catalyst. If it is a metal oxide, which kind of oxides are there? Whether the mixed oxide is there? Such kind of decisions are taken as a catalyst formula. Then there is one more thing which is added, is the reaction envelope. Meaning to say whether this reaction is being carried out in a inert atmosphere or a reactive atmosphere or whatever. So this is what is we decide and we create these reactions. Based on these decisions, we get the efficiency of the catalyst for carrying out those reactions, and we can develop this catalyst. Now, there was one more area, one more corner which gets added to this, was a particle size of the catalyst. Okay? Now, this particle size of the catalyst was never there in the decision making of this. But when people understood that if the particle size of the catalyst or the material goes down, suppose a metallic catalyst and the particle size of metal goes down to the nano level, nanometers level, it has a different physical and chemical properties. The properties differ, and therefore they can be more active catalyst. And therefore, particle size started mattering. And therefore, entire development into nanotechnology field came up. That particle size matters a lot. As people have understood, everybody started rushing to the nano level. And already people have started about the pico level now. They are going much below the nano level for the properties because they understood that the particle size is also one of the component in the decision making, which will change its property, physical, chemical properties, and therefore exhibit different behavior into the reaction itself. And therefore, this is important. Now, the best example for this particle is gold. Gold, as you understand, is a yellow material which looks like yellow, but the gold at different nano size has very different colors. It looks green, it looks purple, it looks bright red. So different colors are there depending upon the size. So even the physical properties are different. What I wanted to say one more is, can I add, in my group, I am trying to ask people, can we add another corner to this figure? People have said catalyst formula, reaction condition, reaction envelope, particle size is also understood. Can there be one more corner? Can there be two more corners? Can we keep on expanding this corner in any of this direction? And if you can find out something other, you will be the pioneer in that area to generate the research activity or develop an entire area of that research activity, which has happened in case of nanomaterials. So now let's put something on the research priorities. I will be slightly quicker because we are already 1 hour past. Research priorities and method. How do we fix this? And what are the priorities? How do we fix the priorities? So I slightly touched this topic, but I'll just elaborate it now. I said, you look around yourself. You look around yourself and try to identify certain issues which need to be resolved. And that could be your research area. Okay. And for that, what we need to do is you need to look at the local. Just for a second, and just. Okay. Sorry, there was somebody who wanted to have a signature. So look at the around you and try to understand what kind of problem. So I gave you the example of the Bose speaker. Okay. Now, what is furthermore could be, say for example, water bodies in the areas in the town or the villages you are living in. If they are dirty, if they are polluted, and I'm sure they are, okay, who is going to clean them? Who is going to provide the solutions to it? You are waiting for somebody to come outside, then you are not a good researcher. Why are you waiting for somebody from the outside? If you are working in that similar area in the research and similar and in your locality, in your locations, if you have issues, why you are not taking initiatives to resolve it, resolve it through the research. Therefore, need of the local thing, common people, local thing, could be water, could be health, could be food. This kind of local needs need to be addressed. So while giving the purpose, the priorities can be defined like first thing which we are seeing near around or surrounding you, and trying to resolve some of the challenges surrounding it. If you resolve those challenges, you will be generating some purposeful research. Second comes on the national level. National level priorities are, again, suppose water is common in both local need and national need. In the local need, water could be cleaning of the water, or could be removing the pollution, or could be providing the clean drinking water. On the national priorities, water would be like a circular economy in the water area. How do we examine that the entire water in the country would be sufficient enough, and looking at various aspects of receiving the rainfall, having the urban floods, and the kind of the dams which we have built for different purposes of irrigation, hydro energy, and so and so. So this water has got a very big functions, and the national need, if we look at national priorities of this water, how they are looking at, that could be an area of research where we are working for the priorities of the nation. Similarly, for the energy, like today, clean energy is an important aspect and a very, very big thing which we are talking about. Energy and environment together itself, which we are talking about together, very big way today. And we need to understand, because we are still developing. We need a lot of manufacturing and other units to come yet. And if, or even the transportation, if it has to come, then we are definitely needing more and more energy. So while needing more and more energy, how do we save the environment? And also, otherwise, the environment in a larger perspective could be a national priority and is a national priority. So you look at how do we deal with it. So this becomes an area where you can work and you can find out. There could be many more. I'm just giving few examples to within the limited time which I can speak. Then you can move towards. See, we are moving outer and outer. We investigated in the local to national level, and the national to global level. Some of the issues are of global level, like say for climate change. Climate change is something which is global level, like greenhouse gases, which are contributing largely to the global temperature rise, and therefore also some of the aspects which are climate change aspects which have been created. Recently, last year, end of the last year, there was a conference which was COP26 held in Glasgow, and there are a lot of other, every country has given some commitments of reduction in carbon dioxide emissions, or very normally called as carbon emissions from their countries. India has also given some targets for what we need to achieve for 2030 and 2070. Now, this is something which needs a lot of research in those areas. And the climate change would be addressed. It's a global level issue. Similarly, health. I have given you the example of vaccine. So to deal with the pandemic kind of situation, it was a global need. And everybody and anybody in the world could have contributed. India has contributed great in this area. So global needs can be addressed, or global challenges can be addressed through the research. And as I already spoken on the methods, two methods, one is Newtonian approach or reductionist approach, or more towards deterministic method of collecting and analyzing the data. And second is the Darwinian approach, which is more holistic and can include complex situations as well. You need not to simplify the situations. And therefore, if once you fit the priorities, you also choose by which methods you want to go. Are you taking the reductionist approach, or you are going to go by the Darwinian approach? You have to choose that. And let me tell you, an Indian perspective has always been Darwinian approach. You go holistic. If you go holistic, likely chances that you may require more time, you may require more efforts, but your success may be much better, and it will be lasting longer. And therefore, to me, it appears that Darwinian approach has to be more important. So when I said Bharatiya system or the Indian system, Indian knowledge system best is working on is more on the not deterministic, but to the Darwinian approach, evaluation approach. So today, fortunately, those who are in the educational institutes, NRF under the National Education Policy 2020 has recognized the potential of traditional knowledge in the Bharat as well, and traditional methods also. What is the traditional knowledge and the studies which actually Bharatiya knowledge systems and the priority areas? It has always been like, I'm giving you some examples. Say, for example, water treatment by phytochemicals or the phytoremediation, water or wastewater treatment. It is well documented in your traditional knowledge system. We have not used it properly. If you use it properly, we have done it in some cases in phytoremediation unknowingly. After using it, we came to know that it is also reported in the ancient literature, and much more in detail. We have not required so much of experiments to be done, which is already there. So there is another way of looking at the areas where you can depend on the areas which are all the first characteristics of the research project, which I said was empirical. But this empirical means based on the previous researchers' experience, based on the previous documentation. So why do we leave some documentation which is such a great? I'll give one more example which is coming from very modern kind of thing like perfumes. But there is one book which is from the ancient literature. It's called Gandhasara, and it actually explains you a lot of formulations of the perfume which are even not today created. Okay. Why don't we go and why don't we trust such knowledge and try to test them also? And then holistic wellness. Today it is very important in terms of your immunity boosting. Vaccine is good, but vaccine can only work when you have your own immunity system as well. Which can work better. In fact, it's not only work, but it can work better. So what we have taken is like there is a TKDL, traditional knowledge digital library as a repository there. And we have open knowledge systems as well, which was practiced before. Why I'm putting these points before is there are certain very good traditions and very good knowledge systems which we had, and there's a lot of potential there. Some purpose, some areas can be identified from them as well. So just not to find out what is reported in the modern literature only, because what happens many times is we start with the literature survey, we start with finding out 20, 25, 100 papers, and we start following what is reported there. There could be, for going out of the box, there could be something which is written somewhere else. This is still not completely out of the box. Still, you are following something which is written previously, but still at least will give the new dimensions. Like one which I have explained during the catalyst example of adding one more corner to the decision-making triangle. Instead of a triangle, it becomes a polygraph afterwards. And another 1 or 2 slides probably. Another method of how do we select the areas which are important. As I said, from local to national, national to global, but even the reverse is also possible. From global to local, you can come, and this is which is initially there was some 8 Millennium Development Goals which were defined by United Nations. And these goals were like eradicate extreme poverty, achieve universal education, primary education, improve maternal health, ensure environmental sustainability. Several such goals were given, which were agreed by different countries that the world should work towards this direction. So there are enough opportunities to contribute to these goals. And now these goals are expanded into 17 Sustainable Development Goals. So please read SDGs, Sustainable Development Goals. You will find a lot of areas in which you can contribute as a researcher. And every country has given some commitments. And unfortunately, even enough, India is still need to do much better in every of these 17 goals. Our performance need to be increased. And we researchers can contribute greatly into these areas by creating new methods, by creating new materials, by creating new technologies, by creating new understanding, scientific understanding, deeper understanding into solving certain issues, which will result further into applied research. So the 17 sustainable goals are more important. And there are some government programs. And before the programs where you can contribute, probably there is one more thing which I must speak is international treaties. Say, for example, there is a Minamata Convention where we have signed. And this Minamata Convention is stopping of the mercury to come to mercury utilization into various fields. Now, we need to have a research being done for the commitments internationally country has given. Bharat has given commitments. Every country has given. Bharat has also given commitment. And this to fulfill this commitment, there are some national obligations. To fulfill those national obligations, we can select the areas for the research. And then coming to the some areas of the research where we can actually work in the alignment with certain areas. This will be easy for you to convince the policymakers. This will be easy for getting the fundings as well. And probably last but not the least is you align with the industries. There has to be synergy between industries and academic partners. I was speaking in Punjab University. We have created one good synergy over there where almost 200 academic researchers, academicians were kept for the discussion across with 150 industries on one platform. So this actually has created the synergy between what is the industrial need and what are the expertise available with the academic partners, or what is the solution already existing, or what kind of hand-holding they can do for scaling up or having the solutions which can go up to the industries and industry can use it. So this synergy, if you build, then your purpose of the research can be one more purpose of the industrial growth, which has much larger purpose of contributing to the GDP and again, everything for the country's development. At the same time, if you build this trust between industry and academic partners, there's a definitely trust deficit between industry and academic partners. Industry would not so easily trust or believe the data in the academic field, but if you can prove that the data is very correct and it can be used, industries would most likely to get the data and also most likely to fund your research in a great way. And therefore, more research can be done, more contributions to the industries can be done, and this would be a cycle and which will be able to contribute to the more national development. And lastly, but not a few more points, which I'm not going into the detail, but you need to protect your IP generated through IPR protection, which could be patent, trademarks, design, or many other aspects, the copyrights, many other aspects which we get to know. So this is something innovative. Knowledge systems has to be created and then used for industry or society. Budget is not the constraint which I'm just leaving. This is also I'm leaving. Some of the agendas for the project could be environment, agriculture, health, water, food, and energy nexus. Some examples of the proposed project in the sense, the proposals can be created is environmental information system, water body rejuvenation, and so and so. I will stop here, leave some 10 minutes or less, slightly 15 minutes probably, 10-15 minutes for the discussion. So it's possible, every dream is possible with the supports of the or a synergy between the researchers. And here I will stop. Thank you very much for your patient listening. I will stop sharing and we can have discussions.
Thank you, Rajesh sir. So this is very good talk. Really nice talk.
So this is kind of a setting of the tone for next another 9 days, which we are going to have. So what you are looking for, what the messages you want to take up from this particular course and implement into your areas. I'll tell you just one. By the time questions comes, I will tell you one more example. I attended long back. I attended when I was just a young researcher, a course on design of experiments. which I attended at IIT Bombay, which was a DST sponsored course. And there was one professor who came from Delaware University, USA. And he came here for 2.5 days. 2.5 days, he was a single faculty who was taking the course on this. And he's such a wonderful way he has taken. I'm also going to speak on design of experiments in this course. You will understand at that point of time how it is important. In fact, I took it very seriously. I applied it to all of my research now. I actually, whenever I try to get opportunity to learn new things, I'll try to apply it to what the work which we are doing in our lab. And then I have seen that it makes wonders. It makes wonders. Design of experiment could give me the most reliable result with a 95% confidence levels on the statistical scale with just 30-35 experiments. With 4 variables, independent variables, and at least 3 dependent variables, which otherwise could have been more than 1,000 experiments. And even still, you would have not got 95% confidence level. So once you learn something new, try to apply into your field. That is what the message I need to plant before you get exposed to another 9 days for various lectures. So if there are questions, I would love to answer them.
Participants, please type your questions in either question answer area or chat box. Let's see.
There are no questions.
So from participant side, no questions.
If you want to have questions, it still is okay. Any discussion also is okay. Want to add something, some of your experiences also, that's fine. It's not that I'm only taking the course, so everybody is here can contribute.
So I have one question. So because every person comes with some backgrounds. So some is civil background, some is mechanical background, some is computer background. So because in general SDG goal, so this is a sustainable development goal, it may not exactly fit into our what you can say domain of research or our what you can say subject area. So how to fit that thing?
So it is not like that you are solving the entire problem. That's what the jigsaw puzzle is. Yeah. So you need to understand your role, your type of things. Say for example, vaccine development. And if I see that is somebody from the computer science wants to work on vaccine development. Okay. Now this seems to be impossible because it's a medical field where people are working from the medical background. They have their own methodologies, their own constraints. But a computer science guy can create a data management system, data analysis system using artificial intelligence, using combining various data all together, and he can contribute. In fact, when the vaccines were also delivered or even the pandemic was monitored, it was the Arogya Setu app which was important for monitoring, analyzing, fixing the problem, isolating those people, or vaccinating further down the line using COVID as an app. This was contribution by the computer science. This was not coming from the medical field.
As a computer science have actually applicability or using as another tool, maybe.
Yes,
so
that could be the role in the vaccination. That could be the role in the controlling pandemic. For for some other thing, computer science has got their own core area where others will have a limited role, but they will have the role. And therefore, the one which I have not spoken is a transboundary research or the transdisciplinary research, which is also important.
Yeah. So guys, if someone means suppose mechanical engineering guys want to do means development of COVID related means things and how we can help or similar kind of thing, subject research.
In case of COVID, I'll just give an example. NIT Nagpur, VNIT, has developed a simple device to bifurcate into Y shape the ventilator.
Yeah.
So the same ventilator could have been used by 2 patients. At time it was needed because number of ventilators were limited. And how can enhance the numbers by very cost effective method? Just using some pipe structure, Y-shaped pipe structure, but they've designed it perfectly so that you can use the same ventilator for instead of 1 patient, 2 patients. This is something great.
Okay.
It was a contribution by mechanical engineers.
Yeah, thank you. That's very nice.
Yes.
So let's see any other participant gave any.
Is there a difference between the research between science topics and the social science topics? I think there is, of course, when you talk about the topics, there are different topics. But like myself and Sahuji are discussing, these topics are for both science and social science both. Behavioral change, acceptability of the vaccine, discipline to be followed during the pandemic. These were all social science topics. And whereas other topics which we was science and engineering. So difference would be there, but the purpose could be one: resolving the pandemic, using a team which is having different people, different kind of people.
So even in company also they have actually many different teams. Some legal teams also, some social teams also there, some medical teams. Even big companies have also different structures. In industry also they have different kind of structures.
There are 2 hands raised. So they want to ask the questions. Krishna Yadav and Anjani Kumar.
I think so. They have asked in last session also.
So if there are no more questions, shall we conclude? And then we can give instructions for tomorrow's. You can possibly do that.
Okay, thank you, Raji and all participants for attending the things. So we'll meet tomorrow at actually 10 a.m. So the talk will be by Professor Ashish Pandey about approach to research, and we'll conclude for today. I think so because already in that.
Professor Ashish Pandey, I'll just give you a small introduction so that you can come with something to learn. So Ashish Pandey is from the IIT Bombay. He's a professor at Shailesh J. Mehta School of Management. It's in IIT Bombay, and he's a very experienced researcher, and he is working on research methodologies and Bloom taxonomies, and then again he is instrumental in doing some tangible and non-tangible combination of the research, and you will love to listen to him. And he has got some specific things to tell you, and this is very important for tomorrow. I would request all of you to join tomorrow and listen Ashish Pandey carefully. He's a very experienced research professor from IIT Bombay. Thank you.
So should we officially close?
Yeah.
Yeah.
See you tomorrow. Thank you.
Thank you.
Thank you, Aryabhatta Sahu sir. Thank you, Rajesh Biniwal sir. So participants, we will be meeting again tomorrow morning at 10 a.m. and Professor Ashish Pandey sir will be joining us for tomorrow's session. So thank you all. Aryabhatta sir.
Thank you.
Yes, sir. I'll be closing the link from my end.
Yeah. Thank you.
Participants, we have shared this session live. You can visit the ENICT channel and you can revisit this today's session. In case you have missed something, you can revisit today's session. Thank you all participants. Yes, it is already uploaded in YouTube. Visit ENICT IIT Guwahati channel. Then in the YouTube, you will find this research methodology section, and you will get the today's lectures over there. It will be there. Whenever you like to attend those lectures in future, you can go and see those videos.